All right, we are now going into the notes. You should already have them open from doing the bell ringer, but if you somehow X'd out of it or you forget where to go, it's going to be in your weather indicators folder. Notes, weather indicators, clickety-clack on that. All right, so you already started filling this part out. We are now going to move on to surface temperature, air masses, and fronts. So if I look at this, here we go. All right, so making a weather map. Weather data is recorded at thousands of stations, often at commercial airports throughout the United States and the rest of the world. So if you look at this image, this is a station model. We used to have one on the top of the 300 hallway, but I think it broke. So we don't use it anymore, but it's going to collect a lot of different data. They have it at airports. If you think about like why that is, because there's not a lot of obstructions to the weather there. It's out in the middle of the nowhere. Usually airports, there's not going to be a ton of trees and stuff like that in the way. All right. This is an image of the data that weather station will pop out. All right. So these stations record weather data such as temperature, dew point, cloud cover, visibility, base cloud height, amount of precipitation, wind speed, and wind direction, to name a few. And the beautiful thing about this is that it's all pumped into one universal symbol. So every single one comes out with something like this. So you can look at it and you can say, wow, that is darkened in. This cloud it's cloud covered. It's completely covered in clouds at that location. Up and to the left is always temperature. Down and to the left is always dew point. Right, like straight from the left is the current weather. This little stick is the wind direction. These little flags, they call them, will tell you the wind speed. You got pressure in the upper right from this circle and pressure tendency. So every single one is set up the same way, so you always know where to look for each piece of information. All right. Regional patterns in surface air temperatures can be identified on a weather map. So we use isotherms. Those are lines of equal temperature and are drawn to identify air masses and frontal boundaries. So after each station in the whole United States pumps out that station model, they'll look at the temperature specifically and be able to like draw isotherms, these lines of connecting temperature, to see like, oh, hey, this is a huge mass of cold air. Over here is a huge mass of warm air. There's probably some kind of front right here. So that's how they go about doing that. They see what they can chunk together, and then what's in between will be a front. So patterns in surface temperature. Isotherm maps like the one shown above are typically drawn in 10-degree intervals. So on Monday, we're going to do an activity where we are drawing, well, actually we drew all the lines, the isotherms for you, but you're going to have to identify which each of these lines, what each of them are. Okay, these air temperature patterns shown where different air masses and fronts are found throughout the region. So again, if we can connect equal lines of temperature, we can see where chunks of air masses are and then figure out the fronts. Fronts are where you're going to have a lot of storms typically. Now we get to air masses. Air masses are a large body of air with the same temperature and moisture content. We're going to identify and name each one. Cold fronts, it depends if it comes from the land. So if this cold air comes from Canada, it's going to be continental, meaning dry. Whereas if it comes over in the Pacific Ocean right here, that's considered maritime, which is humid. All right, so that's talking about the moisture content. And then the temperature is like, hey, did it come from the North Pole? So is it continental polar air, or is it maritime polar? Or like down here, that air is warm, it's coming from the tropics. So If it's coming off of the Atlantic Ocean, it would be maritime tropical air. If it's coming from Mexico, that warm air is going to be continental tropical. All right, so I think you have an activity. Oh, wait. Hold on. Masses. Okay. Wait. Do you guys talk about fronts? Yes. All right. We need a front quick. So a front is a location where two or more air masses meet. So again, it's going to separate. Here's a chunk of cold air. Here's a chunk of warm air. All right. We know that where they run into each other, we're going to have some kind of front. And remember, that's important to know because that's where storms are going to typically be, where you have this clashing of two different temperatures and moisture content. Okay. So this air right here, it looks like, according to this front, that it's pushing into, these little symbols are going to point to the direction that they're moving. So if it's pointing this way, this whole air mass is moving down into this warmer air mass. Okay. All right. So I'm going to pause. Actually, I'm going to get out of this and do this part with you. So when describing an air mass, meteorologists use terms continental, maritime, polar, Arctic, and tropical. Use the key below to label each air mass with a temperature and humidity. So if it forms over land, I already talked about, not a lot of water is going to be evaporating, so that's going to be a drier air. So continental, and that will be a lowercase c. If it forms over water and is humid then, because it's water is evaporating into it, it'll be called maritime. And the abbreviation will be M. Temperature, if it's very, very cold, it'll be Arctic. And I don't know why, but this will be a capital A instead of like a lowercase. I'm not sure why. Humidity, when abbreviated, is in lowercase. Temperatures in uppercase, I don't know. Just regular cold is polar. And then warm is always tropical. There's no levels of like, this is like super hot equatorial. This is like, it's just these options. All right. So now we're going to label each one of these. Okay. So this air coming from the most northern spot is going to be considered Arctic. Very, very cold. This air right here is going to be considered polar. It's cold, just regular cold. All right. And then the air down here will be tropical. And this is pointing to Mexico, okay? Now you have to look at where is it forming. Is it over the ocean? Is it over land? So over here, it's in the Pacific Ocean. So that's going to be maritime. So polar, maritime, polar. And we always say the humidity first. So I'm actually going to switch the order on these. Sorry. All right. This also is maritime polar. It's over the Atlantic Ocean now. This tropical chunk of air is over the Gulf, so that's considered maritime. This air is coming off the Pacific, it's tropical, so this also will be considered maritime. Maritime tropical, okay? This is coming from Canada, so we're going to say that that's continental Arctic air. And then this right here, this arrow is pointing to Mexico, which is obviously land. So it's forming over that, and it's continental tropical right there, okay? Hey, hurricanes form near the equator in the Atlantic Ocean. So what type of air mass will it come from? If it's over the ocean, what do we call it over the ocean? And then obviously, if it's coming from the equator. If you're not sure, here's the answer. It would be maritime tropical, or we abbreviate it MT. That's what it would look like. All right, so those are your notes for today. Make sure you got them down and do your CK12. Have a good one.